Hi, I'm Sean Gannon, and this is Minute Math, and today we're learning about factor by grouping.
Minute Math, when you need help you use Minute Math.
We're given this problem right here. 8r to the third power minus 64r squared plus r minus 8, and we want to factor this completely. Well, we're looking about doing this by grouping. Notice the first two parts right here. What can we pull out? Well, there's an 8r squared in both parts. So if we pull out an 8r squared, what are we left on the inside here? Well, just an r from the first part, and then minus an 8 in the second part. All right. So what do we have right here? The second part. Well, the second part is already grouped as the r minus 8. So we have it like this. Now, if we pull out, we see in this both part here, multiplication, we have an r minus 8 and an r minus 8. If we pull out an r minus 8 from both of them, right, pulling out, be multiplied by the 8r squared, plus here would be a 1. And there we have it. It can be rearranged, but it's fine, I think, as it is. Our final answer, r minus 8 times 8r squared plus 1. We're given this problem right here. 12p to the third power minus 21p squared plus 28p minus 49. And we want to factor this completely. Well, let's look at my first part right here. What do we see? Well, I see that a 3 goes into 12 into 21. So does a p squared into p to the third power and p squared. So if I pull that from both of these, I'm left with a 4p minus 7 right here. Now let's look at the second part. A 7 goes into 28 into 49. Pull out a 7, and what are we left with? Well, 4p minus 7. So now we notice we have a parenthesis of 4p minus 7 and 4p minus 7. And we have our two parts separated by an addition sign. Well, we can pull out a 4p minus 7 here from both parts, pulling that out, and what are we left with? The 3p squared plus 7. And there, actually, we have our final answer. 4p minus 7 times 3p squared plus 7. We're given this problem right here. 12x to the third power plus 2x squared minus 30x minus 5. And we want to factor this by grouping. Well, first thing I want to do is see in the first part here, what can I pull out that's the same? There's a 2 in both, and 12 and 2, as well as an x squared. If we pull that out, we're left with a 6x, right? So 12x to the third power divided by 2x squared is 6x. And then we're left with a 1 here from 2x squared. What about the second part? Well, the second part, we can pull out, I like to see this as a plus and negative 30x, and like plus and negative 5 makes it a little easier for me. So what do we have? If we pull out a negative 5 from both parts, we're left with a 6x plus 1. And that's good, because we have the first part here has a 6x plus 1, and the second part has a 6x plus 1. Let's pull that out from both parts, and we're left with multiplication left over. 2x squared, and then minus a 5 right here. And there we have our final answer, 6x plus 1 times 2x squared minus 5. We're given this problem right here. 6v to the third power minus 16v squared plus 21v minus 56. And we want to factor this completely. Well, first thing I look at is my first two parts right here. What is common in both of them? 2 can go into 6 and 16, and so can a v squared. V squared goes into v to the third power as well as v squared. So if we pull out a 2v squared, what are we left with? A 3v in the first part, and just a minus 8 in the second. Now let's do the same thing with the second part right here. What is in both parts that are the same? Well, they both have 7 in it. So if we pull out a 7, we're left with a 3v and then a minus 8. Well, we see a 3v minus 8 in both parts right here. So if we pull that out from both parts, we're left with 3v minus 8 multiplied by what's left? 2v squared plus that 7. And now we actually have our final answer. 3v minus 8 times 2v squared plus 7. We're given this problem right here. 63n to the third power plus 54n squared minus 105n minus 90, and we want to factor this completely. Well, first thing I'm looking at here is saying, okay, is there something that actually goes into all three parts? I noticed that. And a 3 can go into all 63, 54, 105, and 90. So to make things easier, I pull that out. 3 goes into 63 21 times, 21n to the third power. Plus here we have 18n squared, plus a negative, I'm going to write it like that, 35n, and then plus a negative 30. Alright, so now we want to try our grouping. A little easier numbers to work with. 3 still comes down. Alright, but we want to see, well, what goes into 21n to the third power and 18n squared? And that's actually a 3n squared goes into both. What does that leave us? Well, 3n squared goes into 21n to the third power 7n times. Same question with 18n squared, and we're left with a 6. Alright, so now we got to do this again with the second two numbers. Well, negative 5 goes into both of these, so we pull out a negative 5, and what are we left with? Well, a 7n plus 6. And that's kind of our goal. Notice the 7n plus 6 written twice here. So 3 is still on the outside, but if we pull out a 7n plus 6 on the inside parentheses, for both of them, 7n plus 6 here, what are we left with? 3n squared plus a negative 5 or minus 5. And there we actually have our final answer. 3 times 7n plus 6 times 3n squared minus 5. We're given this problem right here. 21k to the third power minus 84k squared plus 15k minus 60. And we want to factor this completely. Well, notice 21, 84, 15, and 60 all have the number 3 within it. So if we pull out a number 3, we're left with a 7k to the third power minus 28k squared plus 5k minus 20. So where do we go from here? Well, I notice in the 7k to the third power and 28k squared, we can pull out a common factor here. So 3 still comes down, but we see a 7k squared is in both of these. So if we pull out a 7k squared, what are we left with? Well, just 1k right here, 1k. And here, we're left with just a 4. So 7k squared goes into 28k squared 4 times. All right, second set of numbers. What can we pull out? Well, we can pull out a 5. 5 comes out. We're left with a k here minus 4. Now notice the k minus 4 is written twice. So if we pull that out here, so 3 stays here, we pull out that k minus 4 from both parts, what are we left with? Just that 7k squared, and then plus the 5. And there we have our final answer. 3 times k minus 4 times 7k squared plus 5. We're given this problem right here. 25v to the third power plus 5v squared plus 30v plus 6. And we want to factor this completely. Well, the first part right here, I see that I can pull out a 5v squared from both parts. I pull out a 5v squared, and I'm left with, well, just 25v to the third power divided by 5v squared is just 5v. In the second part, I'm left with just a 1. Alright, second part right here. What do we have? Well, a 30v and a 6 both have 6 in it. Pull out a 6, and we're left with a 5v plus 1 here. Alright, that's the beauty now. We have 5v plus 1 and 5v plus 1 in both parts. If we pull that out, we have 5v plus 1 from both parts that are being multiplied. We're left with a 5v squared plus 6. And now we have our final answer. 5v plus 1 times 5v squared plus 6. We're given this problem right here. 105n to the third power plus 175n squared minus 75n minus 125. And we want to factor this completely. Well, notice all of these numbers end in 5, meaning we can pull out a 5 from all of them. Let's make these numbers smaller. If we pull out a 5 right here, what are we left with? Well, we're left with a 21n to the third power plus a 35n squared I'm going to write it as plus a negative 15n, and then plus a negative 25. All right. So now that we've pulled 5 out of each one of these numbers right here, let's go deal with our groupings. 5 stays down here, but notice 21n to the third power and 35n squared. Both have 7n squared in them. So if we pull that out from both parts, we're left with 3n and then a 5. So now let's go deal with the second part here. Negative 5 is in both parts right here. Pull out a negative 5, and what are we left with? Again, a 3n plus 5. We're almost there. 5 still comes down, but notice there's a 3n plus 5 and a 3n plus 5 right here. If we pull those out, right, of this expression, we're left with 3n plus 5 right here times 7n squared minus 5. And now we actually have our final answer. 5 times 3n plus 5 times 7n squared minus 5. We're given this problem right here. 96n to the third power minus 84n squared plus 112n minus 98. And we need to factor this completely. We're going to pull out a 2 here because we can see that each one of these numbers are even, so we can pull out a 2 first. 2 comes out, we're left with 48n to the third power minus 42n squared plus 56n minus 49. Okay, now here comes the groupings. 2 comes down, and what do we see in 48n to the third power and a minus 42n squared? Is there a common factor there? And that's 6n squared. 6n squared goes into both of these, leaving us with an 8n first minus 7. Again, we're going to ask the same thing of the second two numbers. What number goes into both of these? And that's a 7. So 7, pull out a 7 from 56n, we have 8n. 7 from 49 is a 7. Okay, we're almost there. Notice we have 8n minus 7 and 8n minus 7. So if we pull out an 8n minus 7 here from both parts, we're left with just now a 6n squared plus 7. That's 7 right there. Now we actually have our final answer. 2 times 8n minus 7 times 6n squared plus 7. We're given this problem right here. 28v to the third power plus 16v squared minus 21v minus 12. And we need to factor this completely. Well, let's look at the first two numbers right here. Is there a common factor in both of those? And we see, well, yeah, 4 goes into both, and so is a v squared. So if we pull out a 4v squared from both of these, we're left with a 7v plus 4. Well, now we're going to ask the same thing of the second two numbers. I like to see this a little easier as a plus and minus. That's me personally. But what can we see that's in both of these numbers? Well, if we pull out a negative 3, which goes into both of them, we're left with a 7v plus 4. Again, that's pulling out the negative 3. Well, notice we have a 7v plus 4 and a 7v plus 4 right here. We pull that out, 7v plus 4, from both parts. We're left with that 4v squared minus 3. And now we have our final answer. 7v plus 4 times 4v squared minus 3. We're given this problem right here. 4v to the third power minus 12v squared minus 5v plus 15. And we need to factor this completely. The first two numbers here, I can see that a 4v squared goes into both of them. So if I pull that out, 4, that's a v, let's do that, 4v squared here. I pull that out of both of them, what are we left with? Well, v in the first part minus, well, just a 3. The second part here, again, I like to write these sometimes as a plus and negative when I'm doing this. So plus, what goes into both of these? Negative 5v and 15, that's a negative 5. If we pull out a negative 5, we're left with a v, and this becomes a minus 3. And that was kind of our goal. We have a v minus 3 and a v minus 3 right here. If we pull that out of both parts here, we're left with a v minus 3 here, times, now bring that down, so again we're pulling out a v minus 3 here, 4v squared minus 5. And there we have our final answer. V minus 3 times 4v squared minus 5. We're given this problem right here. 49x to the third power minus 35x squared plus 56x minus 40. And we want to factor this completely. Well, the first two parts right here, notice that a 7 goes into 49 and 35. And so does a x squared, and the x to the third power and x squared. If we pull that out, what are we left over with? Well, that's a 7x, and then minus 5. We're going to do the same thing with the second two numbers here, 56 and 40. Well, 8 goes into both of those. We're left with now 7x minus 5. Notice these are written twice, 7x minus 5. So if we pull out a 7x minus 5 now from both parts, we're left with a 7x minus 5 here times what's left over, 7x squared plus 8. And now we actually have our final answer, 7x minus 5 times 7x squared plus 8. We're given this problem right here, 24p to the third power plus 15p squared minus 56p minus 35, and we want to factor this completely. So what do we notice here? Well, we have 24p to the third power and 15p squared. Is there a common factor there? Well, 3 goes into 24 and 15, and p squared goes into p to the third power and p squared. So if we pull out a 3p squared, what are we left with? Well, we're left with an 8p plus 5. Alright, so now let's still deal with the second half. I like to write this as plus and negative. Plus and negative helps me see this. That's just my personal preference. Well, we have negative 56p and a negative 35. If we pull out a negative 7, which goes into both, we're left with an 8p plus 5 here. And that's actually kind of nice. We see an 8p plus 5 and 8p plus 5 here. Pulling that out from both parts, we're left with an 8p plus 5 times what's left, 3p squared minus this 7. And now we actually have our final answer, 8p plus 5 times 3p squared minus 7. We're given this problem right here, 24r to the third power minus 64r squared minus 21r plus 56. And we want to factor this completely. Well, let's look at the first two numbers here. What do we see? Well, we see that there's 24 and 64, and 8 goes into both of those numbers. We have an r to the third power, an r squared, and r squared goes in both of those. So if we pull that 8r squared out, what are we left with? 3r minus 8. We're going to do this again with the second two numbers. I like to write this as plus and minus. It just makes it easier for me to see. Plus. Well, we have 21r and 56, or negative 21r. If I pull out a negative 7 here, I'm left with a positive 3r minus 8. Well, now we have 3r minus 8 and 3r minus 8 here. Pulling both of those out from both parts, right? We're left with this 8r squared minus that 7. And now we actually have our final answer, 3r minus 8 times 8r squared minus 7. We're given this problem right here, 56xw plus 49xk squared minus 24yw minus 21yk squared, and we want to factor this completely. Well, I like my first parts right here, 56 and 49, xw and xk squared. What's a common factor in both of these numbers? Well, 7 goes into the 256, or into 56 and 49, and an x goes into both of their parts. If we pull that out, we're left with an 8w plus a 7k squared. So now we're going to deal with the second part. Again, I like to write this as plus and negative. That's my preference. Well, we see our two numbers, and negative 3 goes into both of them. Y is also in both of these. If we pull out a minus 3y, what are we left with? A positive 8w plus a 7k squared. Well, that should look familiar. That's the same thing that's written here. We can pull out that 8w plus 7k squared from both parts here. Pulling that out, 8w plus 7k 5k squared. The second part here is 7x minus 3y. Bringing these two parts down. And now we're done. We have our final answer. 8w plus 7k squared times 7x minus 3w. We're given this problem right here. 42m squared, mc plus 36md minus 7n squared c minus 6n squared d. And we want to factor this completely. Well, the first two numbers right here, I can see that a 6 goes into 42 and 36, and an m can be taken out of both of them. We're left with then a 7c plus, right here, a 6d. We're going to do the same thing with the second two numbers. I like, again, to write this as plus and minus. What do we see? Well, an n squared is in both of these numbers. So if I pull out a negative, to kind of get rid of the negative, negative n squared, I'm left with a 7c plus 6d. Again, that should look familiar. We have 7c plus 6d here, and 7c plus 6d here. If we pull that actually out from both parts, so 7c plus 6d, we can bring down these two, 6m minus n squared. And now we actually have our final answer, 7c plus 6d times 6m minus n squared. We're given this problem right here, 12x squared u plus 3x squared v plus 28yu plus 7yv, and we want to factor this completely. What do we see? The first part here, I notice a 3 goes into 12 as well as 3, and an x squared goes into this x squared and this x squared. So if I pull out a 3x squared from these two numbers, I'm left with a 4u plus, well, just a v. So we're going to do the same thing with the second two numbers. Find the common factor. 7 goes both into 28 and 7, and same with the y. Y goes into yu and yv. What are we left with? Well, 4u in the first part plus just a v in the second. Well, now we see 4u plus v and 4u plus v. We see that twice. If we pull that out from both parts right here, we have 4u plus v here. We can then bring down the insides now, or the other parts, 3x squared plus this 7y. And now we actually have our final answer, 4u plus v times 3x squared plus 7y. We're given this problem right here, 40ac squared plus 25ak squared plus 32bc squared plus 20bk squared. And we want to factor this completely. Well, the first two numbers, I can see a 5 goes into 40 and 25, so I'm going to pull that out, and there's an a in both parts as well. When I pull that out, I'm left with an 8c squared plus 5k squared. We're now going to look at the second two numbers and do the same thing. 32 and 20 both have 4 that can be taken out of them, and both of these have a b. So we're left with, well, pull out a 4b from both parts, an 8c squared plus 5k squared. And notice we have 8c squared plus 5k squared written twice. We can take that parenthesis then and pull that out from both of these parts. We pull out an 8c squared plus 5k squared from both parts. And we're left with, well, bring down the 5a, bring down the 4b, and that is our final answer. 8c squared plus 5k squared times 5a plus 4b. We're given this problem right here. 12bc minus 4bd minus 15xc plus 5xd, and we need to factor this completely. Well, the first two numbers here, I notice there's a common factor. I can pull out a 4, and I can pull out a b, which is in both parts. We pull out a 4b, what are we left with? A 3c in the first part, and minus just a d in the second. Well, we're going to do the same thing with the second half. I like to write this as plus and minus, personal preference. What do we see? Well, can we pull out a common factor? And yeah, I can pull out a negative 5x. If I pull out a negative 5x, the first part becomes a 3c, and the second part becomes a minus d here. Notice we have 3c minus d written twice. We pull that out from both parts, 3c minus d here, and we're left with, bring down this 4b, and then a minus 5x right here. Bring those two down, and now we actually have our final answer, 3c minus d times 4b minus 5x. We're given this problem right here, 16mn minus m squared plus 28n minus 7m, and we want to factor this completely. Well, notice the first two numbers right here, 16mn and 4m squared. Both of them have, well, 4 goes into 16 as well as 4, and both of them have an m in it. We pull that out and we're left with, the first part just has a 4n, the second part is just 1m, so we have minus an m here. We're going to do the same thing with the second part. Well, 28 and 7 both have a 7 in it, we pull out a 7, and we're left with, well, just a 4n minus m here. Notice 4n minus m is written twice. We pull that out from both parts, 4n minus m here, and what are we left with? Well, bring down this 4m plus 7. Squeaky. But now we actually have our final answer full of m's and n's, keep them straight, 4n minus m times 4m plus 7, and again that is our final answer. We're given this problem right here, 56xy minus 35x plus 16ry minus 10r, and we want to factor this completely. Well, notice the first parts, 56 and 35 both have a 7 in it, and xy and x both have an x in it. We pull out a 7x, and we're left with here just an 8y minus, well, 5. The second part, we're going to do the same thing. 2 goes into 16 and 10, and there's an r here in the ry as well as the r. That leaves us an 8y minus 5 left over, and that should look familiar. We see that written twice right here. So if we pull out an 8y minus 5, right here, we're left with, well, 7x comes down and a 2r. I almost called it 24, but it's 2r. And now we actually have our final answer, 8y minus 5 times 7x plus 2r. We're given this problem right here, 21xy plus 15x plus 35ry plus 25r, and we want to factor this completely. We can pull out here, well, we look and see there's a common factor. 21 and 15 both have a 3 that can go into it. And then x, y, and x both have an x that can go into it. So what are we left with? Well, we'll pull out a 3x here of 21xy, and we have a 7y. 15x, we pull out the 3x from there, and we're left with just a 5. So now we're going to do the same thing with the second half. We have 35ry and 25r. Well, 5 goes into both of these, and so does an r. We pull out a 5r, and we have a 7y plus 5 here. So now 7y plus 5 is written twice. So since it's written twice, right, in both parts, let's pull that out. Pull out a 7y plus 5 here. Bring down the 3x, and the 5r are left over. And we actually now have our final answer, 7y plus 5 times 3x plus 5r. We're given this problem right here, 5a squared z minus 4a squared c plus 15xz minus 12xc. And we want to factor this, well, completely. Well, the first part right here, I can see that there's an a squared and a squared both in the first part. So if I pull that out, I'm left with just a 5z minus, well, 4. 4c. 4c. Whoops, almost forgot the c there. So 5z minus 4c when we pull out an a squared. Second half, we gotta see what's a common factor. 3 goes into 15 and 12. And there's an x here in the xz and the xc. So we can pull out a 3x. What are we left with? Well, that's again a 5z minus 4c. We see that's written twice here in both parts. So if we pull that out, a 5z minus 4c, don't forget that c, we're left with that a squared and then the 3x that comes down. And so we now actually have our final answer, 5z minus 4c times a squared plus 3x. We're given this problem right here, 4xy plus 6 minus x minus 24y, and we want to factor this completely. Well, the first thing I'm going to do is kind of group my like terms together. I have 4xy here, but then I can put my minus x next to it. I'm then going to put the minus 24 here, 24y, and then my number 6 at the end. Well, from here, I see my like terms I can pull out, which is an x. X is in both of these, so I'm going to pull out an x. What am I left with? Well, it's a 4y and then minus a 1. This minus 24y, I like to write that as plus a negative. So we have a plus here, and then we're going to pull out, well, what's in 24y and 6, or negative 24y? And that's a negative 6. So I'm actually going to pull out the negative 6 here, leaving me with a positive 4y minus 1. And that was on purpose, because I can have 4y minus 1 and 4y minus 1 here, both written twice. They're both in both parts here, or each one's in both parts. So I can pull out the 4 minus y, or 4y minus 1, and bring down now the x minus 6. And we now actually have our final answer, 4y minus 1 times x minus 6. We're given this problem right here, 21xy minus 12b squared plus 14xb minus 18by. And we want to factor this completely. Well, first thing is I'm actually going to rearrange this expression to have my like terms or similar terms together, similar variables. So I'm going to bring down the 21xy, but then I'm going to bring over this 14xb. I see there's an x in both of them. I'm going to write the 18by down here, and I'll make it a plus or minus 18by. Then I can bring down this minus 12b squared and plus minus 12b squared, and they both have a b in it. So now we want to pull something out here. 21 and 14 both have a 7 in it. They both also have, or xy and xb has an x in it. So from there, if I pull that out, I'm left with a 3y plus a 2b. I'm now going to do the same thing with the second two numbers. They both have a, negative 6 in them, and they both have a b in them. If I pull out a negative 6b from both of these parts, I'm left with a 3y plus 2b. Does that look familiar? 3y plus 2b and 3y plus 2b. Since there's one of them in each part here, each half, I can pull that out, and I'm left with a 3y plus a 2b here, times what's left over, 7x, minus a 6b. And there we actually have our final answer, 3y plus 2b times 7x minus 6b. We're given this problem right here, 9mz minus 4nc plus 3mc minus 12nz, and we want to factor this completely. Well, I'm going to actually rearrange this and try to put similar terms together. I'm going to bring down my 9mz here, and I see, this m, they both have an m here, and they both 3 and 9. 3 goes into 9 pretty evenly, so I'm going to bring that down, 3mc. I then am going to put my 12 nz, but I'm going to make it a plus and minus instead of minus here, plus a negative, 12 nz, and bring down the last part, again plus a negative, 4 nc. They both have an n in it, and 4 goes into both of them. So now we're going to pull out a like term here. The first half here, both of them have a 3. 3 goes into 9, 3 goes into 3, and they both have an m in them. If I pull out a 3m, I'm left with a 3z plus, just 1c. I'm not going to do that again with the second two numbers. A negative 4 is in both parts, as well as an n. If I pull out a negative 4n in both of these, I'm left with a 3z plus c. And make sure you keep the negatives and positives in line. We're pulling out a negative 4n. Well, I have a 3z plus c and 3z plus c written twice right here. Pull that out from both parts, right? 3z plus c, and I'm left with this, 3m minus 4n, bringing that down. And now we actually have our final answer, 3z plus c times 3m minus 4n. We're given this problem right here, 28xy plus 25 plus 35x plus 20y, and we want to factor this completely. Well, I want to rearrange my expression here to have my similar terms next to each other. So I'm going to write down this 28xy, but I'm going to bring the 35x over because they both have an x in them. Bring down now the 20y, and then I'm going to bring over the 25. Okay? And you get better at making a good guess on where you need to rearrange these things as time goes on. Well, we have 28xy and 35x. 7 goes into 28 and 35, and x goes into both of these as well. So if we pull out a 7x, we're left with a 4y plus a 5. We're going to do something similar with the next two numbers. 20y and 25 both have a 5 in them. We pull out a 5, and we're left with a 4y plus a 5 here. So where do we go from there? Well, we have 4y plus 5 and 4y plus 5, both here in both parts. If we pull out a 4y plus 5 from both parts, we're left with then, well, a 7x comes down and a plus 5. And we actually have our final answer, 4y plus 5 times 7x plus 5. We're given this problem right here, 30uv plus 30u plus 36u squared plus 25v, and we want to factor this completely. Well, notice they might not be necessarily in the best order, so I'm going to rearrange this to have some of my similar terms together, but I'm kind of being smart about it, okay? So what I'm looking for here is I see a 30uv, I'll bring that down, and I'm bringing over actually this 36u squared. Then I'm going to bring down this 25v here, and then bring over the 30u. Okay. So I rearranged this, and notice I have like a v here, and then there's a 1u and 2u's here, and no u's and 1u here. And you'll see why in a minute how this becomes helpful. I'm going to pull out a common term. 6 goes into 30 and 36. So we have 6 here, and there's also a u in both of these. So if we pull out a 6u, we're left with a 5v plus, well, again, a 6u here. We're going to do the same thing or something similar with the next two numbers. 5 goes into both of these numbers. 5 goes into 25 and 30. So if we pull out a 5, we're left with a 5v plus a 6u. And hopefully now you can see that our goal was we have a 5v plus 6u and 5v plus 6u written twice. So there's one on each side here. If we pull that out, we have a 5v plus 6u here, and we're left with, well, bring down this 6u and this 5 right here. And now we actually have our final answer, 5v plus 6u times 6u plus 5v. I hope this video was helpful for you, and if it was, please subscribe to this YouTube channel and like this video. This helps us make more free math lessons for you and for everyone else. So as always, thanks for watching.
Minute Math. When you need help, you use Minute Math. Minute Math. Minute Math. When you need help, you use Minute Math. MinuteMathTutor.com.